Welcome to tutorial 4, where we will be learning about making comparisons. In this tutorial, we will be working with the dependent and independent variables. We will learn how to address common hypothesis testing situations. The first is when the independent and the dependent variables are both categorical, that means nominal or ordinal. And then we will look at when the independent variable is categorical and the dependent variable is interval. We will also learn how to create line charts and bar charts. We will first begin with cross-tabulations. Getting the rows and the columns right in cross-tabs will be a bit tricky at first, so it is important that you observe 3 rules. First, put the independent variable on the columns and the dependent variable on the rows. Second, always obtain percentages of the independent variable and not the dependent variable. And third, interpret the cross-tabulation by comparing the percentages of subjects who fall into the same category of the dependent variable. Let's look at an example. We want to look at the hypothesis on page 60, which says that in comparison of individuals, older generations will pay more attention to political campaigns than will younger generations. In the dataset NAS 2008, we have the variable camp_int, which is the interest in the campaign. So we will use tabulate. Type in tab and the dependent variable, in this case camp_int, and followed by the independent variable, which is yob3, which we created earlier. And remember the weights, and type column. What this told Stata is that the dependent variable, which is the campaign interest, will be in the rows, and the independent variable will be in the columns, and that's the generations. And the add-up of the percentages will be those who fall into the same category of the dependent variable. So in this example, campaign interest percentages among those who were born in 1949 or before. The presence of the frequencies here, due to the weights, create a bit of clutter, and it can be suppressed. Just bring back the same command and edit by adding no freq for no frequency and no key for eliminating the key commands, and this will tell Stata to give us a neater table. Looking at the results, we conclude that younger people have lower levels of campaign interest in comparison to older people. Let's take, for example, the high campaign interest. We can see that for the older generation, it stands at 59.57%, whereas for the youngest generation, it's at 37.29%. And for the middle generation, it's 53.32%. So we have a variation here. Also, with the low campaign interest, we find that the older generation have a lower percentage of having low campaign interest at 11.8% in comparison with the younger generation at 21.89%. Now, suppose you want to compare means. A common hypothesis testing situation is with a categorical independent variable and an interval level independent variable. What is different from the previous comparison that we made is that now, instead of comparing percentages, we want to compare means. So let's do an example. There is a variable in the dataset called Obama Therm. This is a 100-point feeling thermometer where respondents were asked to rate Obama on a scale from 0 being negative to 100 being positive. In addition, there is a variable called Party ID 7, which measures partisanship in 7 ordinal categories from weak Democrat to weak Republican.
The syntax is a little bit different in that we start with the independent variable as opposed to the dependent variable, which we just did. So we tap Party ID, which is the independent variable, and we insert the weights here between squared brackets. This is followed by a comma, and then the sum command, and between brackets, the Obama Therm variable. Remember, with time, you will become more familiar with these commands.
As you can see, the command produced for us the mean, the standard deviations, and frequencies, which are all the default for this command. However, in Stata we can always change the default. So suppose you only want the mean, you can edit the command and add to it no ST, meaning no standard deviation, no freq, meaning no frequencies, and no obs, meaning no observations. And we will have here a simpler table, which can give us a quick indication on our hypothesis. Looking at the results, we can conclude that the higher the Democratic partisanship, the higher is the mean on the Obama thermometer results, and the strongest Republicans have the lowest Obama thermometer results. What we want to do now is to create a new variable. We will look at a command that will generate for us a group mean that shows mean Obama ratings for each partisan group. This command is called _gwtmean, a command which is not initially installed in Stata. But remember the discussion we had in tutorial 1 where you can search for commands? Well, there's also another trick, which is to type find it and the name of the command. So if we type find it and the _gwtmean, Stata will lead you to a link from where you can install the command. You can do this for many commands which are not initially installed in Stata. Notice the syntax that we have typed in. If you notice, we have included an exclamation mark here, and that is preceded with an if. This is called the if qualifier. The if qualifier allows you to apply the command selectively to a subset of cases. This if qualifier is very useful and is one of the most frequently used tools in Stata. What this command is telling Stata is to generate a group mean variable which equals the mean of the Obama therm variable for each group, and if the value of the Obama therm variable doesn't equal a missing value. We're going to use this variable in the graphics section of our tutorial. But before we move on, do you recall when we created the married variable from the recode command? What we will do now is to create the same variable again. However, we are going to use the generate command with the if qualifier that we have talked about. Type in gen married2 equals 0. What this is telling Stata is to create a new variable which is called married2 and that this variable equals 0. We will now use the replace command. We will tell Stata to replace married2 values of 0 and make them equal to 1 if marital equals 1, and with the if qualifier, equal has to be typed twice. If marital equal 1. Finally, to account for the missing value, we ask Stata to replace married2 equals missing if marital, the original variable, also equals missing. Equal missing. We can tap the married2 variable and see if we did it right. We can also add a suffix to the command by putting comma miss, and what this will show us is a tabulation of the values as well as the missing values. Now let's turn to graphics. Remember, graphs can be created by typing commands or by drop menus from the menu bar. Go to Graphics, click on the two-way graph. Click on Create, highlight Line, which is the type of graph that we want, and insert the dependent and independent variables. PID 7 underscore Obama and party ID 7. And click on Sort on the X variable so we are sure that the data is graphed in the correct order. We can either click OK or Submit. The difference is that Submit keeps the box open for us in case we want to do some more changes. For now, let us click OK. We see a simple graph as a result of the two-way command. But suppose we want to edit this graph. Go to File and click Start Graph Editor. Within the editor, you have many options to make the graph look the way you want it to. Let's change the y-axis title. Let's give the chart a title. And let's change the thickness of the line. And these are just a few of the things you can do. It is a good idea to try different things with the graph to help you visually show your data. Finally, we want to learn how to graph a categorical dependent variable. The graph we will produce is one which shows the percentage of high campaign interest by generation. And to do this, we need to create a new variable. This variable is high campaign interest. Remember, in the last tutorial, we learned how to create a dummy variable. This is done the same way. Let us type camp_int and insert the weights, comma, and gen camp dum. Stata has created 3 dummy variables. We can see them at the bottom. Remember, we created those variables as we want to produce graphs, so it would look more attractive if these values are percentages as opposed to proportions. Here we can use the replace command. But be very careful, the replace command will destroy the variable you are replacing, so be very careful when you are doing it and be sure that you want to do it. So here we will replace the campdum1 into a percentage value, so we type replace campdum1 equals 100 times campdum1. We click on Graphics and we choose Bar Chart. We select Graph by calculating summary statistics, and in the statistics to plot, we want the mean of campdum1 variable, and click on the vertical orientation. And we go to Categories, select Group 1, and type in YOB3. We click on Weights, and we select Analytic Weights, and we click OK. And here we have our graph. Of course, we can still edit the graph, and after some editing, this is what the graph can look like. This brings us to the end of tutorial 4. Remember to save your work. And now let us move to tutorial 5, where we will learn about making controlled comparisons.